All right, so we're going to take that LCD of 6n and we're going to multiply each fraction by 6n. So let's do that. Let's do 4 times 6n over 3 minus 7 times 6n over, that one was over n, is equal to 1 times 6n over 6. Okay. Now we're going to look through and we're going to see what simplifies. For every single one of these, the denominator should disappear. So for that first one, 6 over 3 reduces to 2 in the numerator. So we've got 4 times 2n, which is 8n. Minus, for the second one, we can cancel the n. So we've got 7 times 6, which is 42. Is equal to, for the last one, we can cancel those 6's, and 1 times n is simply n. So now, our denominators are gone. We've just got a simple linear equation like we had yesterday when we first started these. We've got a variable on both sides. I usually don't like there to be negatives involved, but since the variable is by itself on the right side, I'm going to move the 8n over there. So we've got negative 42 is equal to negative 7n, and then divide both sides by negative 7. 6 is equal to n. Take 15 seconds to check this. Okay, plug it in. 4 over 3 minus 7 over 6. We really don't need any parentheses here because we've just got single numbers in the numerator and in the denominator. And if you didn't know, that is the decimal value of 1/6. So 6 is our answer here. Okay, so let's do the same thing with number 8. We've got k in 2 of our denominators, and we've got 2 in the other denominator. So our LCD is 2k. So we are going to multiply each and every fraction by 2k just in the numerator. Now, I don't actually multiply it out because the whole purpose of this is the denominator should cancel every single time. So I'm not going to multiply it completely out. I'm just going to write it up there in the numerator. So here we can cancel the k's in the first one. So 3 times 2 is 6. Minus, don't lose those pluses and minuses. In the second one, the 2's cancel. So we've got 1 times k, which is k, is equal to, and the last one, the k's cancel. So we've got 12 times 2, which is 24. So if we solve this, we've only got one variable, so we want to get it by itself. Subtract the 6 from both sides. So we get negative k is equal to 18, which means positive k is equal to negative 18. Again, take 5 to 10 seconds to plug this back in. Okay, 3 over negative 18 minus 1/2. Is that equal to 12 over negative 18? It is. Okay? It's as simple as that. Now, let's look at 9 and 10. Okay, the denominators in 9 and 10 look just a little bit different than the ones we've been looking at because they're binomials. They have 2 terms in them. So we've got to be a little bit more selective when figuring out our LCD. When you have more than just a single term in the denominator, you need to ask yourself, can I factor anything? And in this case, we can. We can factor that last denominator right there. P squared minus 4 is equal to P plus 2 times P minus 2. Now, the whole point in doing that is to notice that we've got some overlap here. P minus 2 is shared by those 2 denominators. One other thing, that plus 2 there in the middle, go ahead and put it over 1, just so that we kind of have in our mind that that is another fraction, even though it's not really a fraction, we'll make it look like one. Okay, so our LCD here is p minus 2 times p plus 2. Okay, p minus 2 times p plus 2. That takes care of everything that we have in our denominators. So let's go through and we multiply each one. We're not actually multiplying it out. So p times p minus 2 times p plus 2, that's over p minus 2, plus 2, you got to multiply the 2 as well. And I'm going to keep it over 1 just so that we have that fraction idea in our head. And then the last one as well. Okay, so you multiply each and every fraction there by the LCD, p minus 2, p plus 2. Okay, let's see what cancels. In the first one, what shows up in the numerator and in the denominator? P minus 2. So we are left with p times p plus 2. The denominator's gone. That was supposed to happen. In the second one, it's over 1. Nothing cancels here, so to save myself a little bit of time, when I write it down, I'm going to go ahead and multiply the p minus 2 times the p plus 2, which is p squared minus 4. How do I know that so quickly? Well, I factored it at the very beginning of the problem. Okay, and then how about for that last one? What cancels? Both of them, right? P plus 2, p minus 2, we're left with the 8. Don't lose the 8, it's still there. So our denominators are gone. It looks like we're going to have a quadratic equation because I already see a p squared there.
Pardon this interruption. At this time, I need any junior that needs to have their picture taken needs to report to the media center at this time. Thank you.
Any juniors in here miss it the first time? Okay. Okay, so what I did while the announcement was going on, I distributed the p and I distributed the 2. Okay. Now, this is a quadratic equation, so that means everything's got to be on one side. I need to combine like terms. So I've got a p squared into 2p squared, so that means I have 3p squares plus 2p. Now be careful, some of you are going to want to cancel that 8, but it doesn't actually cancel. If we subtract 8 from both sides, negative 8 minus 8 is negative 16. Equals 0. Okay? So we need factor. Do y'all want to factor it like that, or do you want to use slip, divide, slide? Slip, divide, slide? Okay, so let's do that. Slip the 3 to the end. So that gives us minus 48. Let's see here, factors of 48 that are going to add to give us 2. Well, let's see here. When I think of 48, I think about 4 and 12. That's not going to work. 6 and 8. There we go. That's a good one. Positive 8, negative 6 is going to give me plus 2 when I add those. Okay, I'm not done, right? I got to divide. I got to divide by 3. 8 over 3 does not reduce, so the 3 slides. 6 over 3 does reduce to 2. So 3p plus 8 equals 0, p minus 2 equals 0. So the easy one is that p equals positive 2. The other one, we subtract 8. Sorry, I'm running out of room, so I can't show all my work. And then divide by 3. So negative 8 over 3 is an answer. 2 is an answer. We gotta check it. We gotta check it. Let's check the easy one first. Let's check 2. Okay. Now, this time I do have to have parentheses because I got more than one number in the bottom. So I got to put parentheses around the 2 minus 2. Plus 2. Oh, look what happens when I press enter. I get an error message. It says divide by 0. Look at what's happening. When I plug in 2, I've got 2 minus 2 in the denominator. That causes me to divide by 0, and that is not allowed. So even though we got it as an answer, 2 is what we call an extraneous solution, okay? P cannot equal 2 in this equation because it causes us to divide by 0. Let's check the negative 8 over 3. Okay. Hopefully this one works because then I don't have another option. Okay, parentheses, negative 8 over 3. Divided by parentheses, negative 8 over 3 minus 2. Plus 2. So that's what my left side equals. Good, I'm not dividing by 0. 8 over parentheses. Now, you got to be careful with this. Anytime you square a number, you got to put it in parentheses. I'm going to put negative 8 over 3 in parentheses, squared, minus 4. Close my parentheses. Okay? So negative 8 over 3 checks out. Okay? So get number 10. Number 10. It looks like we have 3 different denominators, doesn't it? They look completely different. But what did I say that we need to do? If there are 2 terms in any of your denominators, you need to see if you can factor something. Can we factor any of these denominators? Yes, we can. We can take a GCF out of that first one. We can take out a 3, factor out a 3 out of that first denominator, and looky there, we've got overlap. We've got W minus 1 in 2 of our denominators. So that means our LCD is between 9 and 3. 9 is all we need. We don't need both 9 and 3. Okay, we just need the 9 and the W minus 1. Okay, so let's see what we've got here. We've got 13 times 9 times W minus 1 over 3 times W minus 1 minus 1 times 9 times W minus 1 over W minus 1. I'm going to put it in parentheses just so it looks like what's in the denominator, is equal to W times 9 times W minus 1 over 9. Okay, so all I did was multiply all the numerators by the LCD, 9W minus 1. All right, now it's the fun part. We get to cancel a bunch of stuff. And the first one, W minus 1 cancels. 9 over 3 simplifies to give us 3. 13 times 3 is 39. Minus, and the second one, the W minus 1 cancels. 1 times 9 is 9. Is equal to, in the last one, the 9 cancels. So we've got W times W minus 1. So this doesn't look too bad. 39 minus 9 is 30. Distribute that W. W times W is W squared. W times negative 1 is negative W. It's a quadratic, so everything's got to be on one side. It's got to be equal to 0. So we got to move that 30. This one's not as bad to factor. All right, our leading coefficient's 1. So we know we've got W times W. 30 is negative, so one of them's a plus, one of them's a minus. How about positive 5 and negative 6 will give us negative 1 in the middle. So our 2 solutions, W plus 5 equals 0, W minus 6 equals 0. So we get positive 6 and negative 5. Are either of those going to cause the denominator equal 0? What would cause the denominator to equal 0? 1, right? 1 minus 1 is 0. So we don't have that issue to worry about. So probably both -5 and 6 are answers, but can't hurt to check, right? 13 over 3 times -5 minus 3 minus 1 over parentheses -5 minus 1. Does that equal -5 over 9? It does. Okay, check 6 really quick. Change all my -5s to 6's. And 6 over 9 is that decimal. Okay, so both of those work out here. Now, part of the reason why I'm showing you how to check your answers is because your test, all of the tests in here are multiple choice. So you always have answer choices. If the question is asking you to solve an equation, what can you always do? Plug in the answer choices and see which ones make the left side equal the right side. If they don't, then they're not it. But you got to be careful. You've got to be careful with these because you've got to put parentheses in the right place. Okay, you've got to have parentheses in the right place or it's not going to work out. Okay, notice I have parentheses around that denominator there because there was more than one number in the denominator. And I've got a parentheses around the second denominator because there was more than one term in the second denominator. Okay, so I want you to try numbers 11 and 12 there.